So welcome to all of you. Today we will again discuss the another classification technique. That technique is a KNN, that is a K nearest neighbor algorithm, and we will try to implement this algorithm by using Python programming.
So let us discuss about KNN algorithm. So here with the help of KNN algorithm, I'm going to use this diabetic data, which will help us to find out that given patient having certain inputs, either he is having a diabetes or not. So that is that is the idea behind it. So let us recall how this KNN algorithm will work. So basically this KNN is a algo, or you may say it is a logic that classify a new data point based on its nearest neighbors. So a group of neighbors are selected, that is a K value, based on the K value, and the data point is classified under that class to which majority of the neighbors belongs. Here basically this K number represent the nearest neighbor which we are selecting. So choosing K value properly will give more accuracy. So choosing right value of K is actually called as a parameter tuning. So if you will see over here in this example, let's say this is my input data, and I want to classify this data, right, by using this KNN algorithm. So if you will choose this KNN algorithm, and if you give this K value is equal to 3, then as per this algorithm, this unseen data is going to be classified as a triangle, right? Because in this neighborhood, 3 nearest neighbor, you may see here we are having this 2 triangle and 1 star. Hence, majority of element in that vicinity belongs to this triangle class, right? So whereas if you give this K value is equal to 7, then you will see that in this vicinity of the highest possibility that new element will belongs to this star, right? So when K is equal to 3, the new element is predicted by KNN classifier as this triangle, and when K is equal to 7, the new element is predicted as a star. Thus, you understand that this K value influences the final decision taken by the KNN classifier. That's why choosing the K value properly will yield correct result from the classifier. So that is a main takeaway point from this theory, right? Now let us implement this KNN algorithm by taking this diabetes data set. So basically this data set contains 9 column and 768 rows. Let me show you that one. So this is my diabetes data set. You may see there are 768 rows are there, right? So and there are basically 9 columns we are having with us. So this column represent how many pregnancy the patient had, glucose level, blood pressure, skin thickness, insulin level, BMI, diabetes pre-degree function that represent the let's say the likelihood of getting diabetes depending on the family history, and the age and outcomes also we are having. This last column is the outcome, and in this if you see it contains this 1 and 0. This 1 indicate that patient has diabetes, and this 0 represent that patient does not have the diabetes, right? So if we will to understand about this data set, I have used this function info. So here you may see this there are this 9 columns we are having, and this many values are there. This is the different data type corresponding to each feature. Total this data frame will occupy 54.1 KB space, right? So this initial understanding will obtain by this. So when we observe this data set properly, so you may see here number of let me show you this one. See, this insulin is 0, and somewhere blood pressure is also showing as 0, right? And pregnancy is 0, fine, but glucose level is also showing somewhere zeros, right? So that is not something appropriate with respect to this context, right? In BMI feature also we are having an input like a 0, right? So we have to handle this part. So what we have to do is we have to replace any zeros in this column with their respective mean, right? So that is something which we have to do as a sort of pre-processing. So to showing you that how many values are 0, and I have executed this one. So what I'm doing here is I'm taking each column one by one, and I'm replacing 0 by NaN value, so that you may see that how many values in each columns are 0 that actually replaced by this NaN. So if you will do this, you will see here that glucose is having 5 NaN value, blood pressure is having 35 this NaN value. Similarly, others we are having where we are getting this zeros, which we are substituted by NaN. So what I did for that, let us prepare the data set by replacing 0 by mean value in various column, right? So what actually I did over here is we replace 0 by this NaN, and in this second line we are calculating the mean value by not taking this NaN value into consideration, and in this third line this NaN values are replaced by this mean value. So once we do it, now I mean this is a sort of pre-processing, right? So all this 0 values is actually replaced by this NaN by this mean value, right? So that is the idea. I mean that is something which we have done as a part of pre-processing. Okay, now let's move. Now we have to here split our initial features and target data. So all the feature from 0 to 7, 0 to 8 is actually the X, and the last column is actually our Y value, our target value, right? So that part we have separated. Now we have to apply this KNN classifier. So as we know, we have to split the data as the next step of MLDLC. So this is a function which we are calling from this sklearn package, and this is the module where this method is present. And after that we have to pass this many parameter to this function, and as a result it is going to return this 4 value as an outcome. Fine. Now to find the k value where the high accuracy can be obtained, we have to use a for loop with various k value, and the accuracy level of the model are I mean we are projecting over here. So if you see it here, let me show you this one. In this case, from this output you may see that we can understand that k value at the k value is equal to 14. The performance of the model is high. It is showing like a 72.22% accuracy. So this can be confirmed by drawing a line plot between the k value and the accuracy score. So for that regard, what I did, I have used this line plot. So you may see here we can get this highest performance of the model when the k value is equal to 14, right? Now that is something which we can visualize by this graph. Now we can also make a prediction by passing this new data to predict method, right? For example, I mean the accuracy of the model which we have chosen, the accuracy of that one is 72.22 that we have seen, right? So here we have let's say, I mean we have to predict a person with a pregnancy is equal to 1, glucose is equal to 189, blood pressure is equal to 60, and this 23 was I guess skin thickness, and then insulin level is this much, and BMI was of BMI of that person is 30.1, and this diabetes pre-degree function value is equal to 0, and age is equal to 59, right? So this many column we were having. So we have to predict that based on this input value, either this person is having a diabetes or not. So if you give this value to as an input to our model, so you will see our model is predicting it as a 1, that indicate that the person is having a diabetes, right? So we may take another example over here. So again, I have given the same feature as the input to this model. Now as per that, my model has predicted as a 0 as the outcome of that, which shows that the concerned person is not having a diabetes as per the KNN model, right? So the important takeaway point from this KNN is this one. So the salient point behind the KNN is this. This KNN classifier is the algorithm that classify the new data point based on its nearest neighbor. In KNN, K represents the number of neighbors selected by the model to decide the class of the new data point, right? The third important point is depending on the K value. See, this is very important. The result given by KNN model will change, right? So this K value selection is very important. That's why this K is nothing but the hyperparameter, right? So K value is mainly selected based on for which K value the KNN model gives the highest accuracy. So KNN basically uses this Euclidean or Minkowski distance to find out the nearest neighbor. Basically this Minkowski distance is a combination of both Euclidean distance and Manhattan distance. So this is a salient point behind the KNN classifier. So we have discussed about the salient point behind the KNN. Now, few of the things are the, if I will summarize the algorithm of KNN, so I may say that this many steps this KNN algorithms are having. Firstly, we'll start with the selection of this K neighbors, right? We have to choose this K number wisely, right? Because as we have seen, this K value, if the K value is not proper, the entire classification will be changed, right? And after that, we have to calculate the Euclidean distance, right? K nearest neighbor distance we have to calculate by using this Euclidean distance, right? Then the neighbors we have to find out, then we have to check the data point in each category, and then we have to find out the majority, right, in that neighborhood, right? And based on that, this KNN will work that in which class the new data point will classify. Now, while using this KNN model, most of the data scientists and data analytics professionals take the value of K depending on a number of criteria. So those criteria we must understand. So let me show you how to select the K value. Before that, let me tell you this distance measure formulas, right? Because we basically calculate the distance. This KNN is using the distance between 2 points, right? It is based on this principle, and these are the formulas which we can use for calculating the distance. We are having Euclidean distance, we can use the Manhattan or Minkowski, and we have seen this Minkowski is nothing but it is using the Manhattan and Euclidean distance both, right? We can also go with this Hamming distance. So these all our options are available in this sklearn library. You have to pass this parameter, which parameter you want to use for calculating the distance. Okay. So with this, the most important point is how to find out the K value, right? So if you see this in this example, we have what we did, we have done the cross validation, right? I have given the different value of K, and corresponding to each value of K, I have find out the accuracy. That is the best approach, right? So, and out of this, I am having K value and corresponding accuracy. I have figured out that at the value of K14, I am getting this better accuracy, right? That is the one way of selecting the K. Whereas these are actually the the way through which we generally calculate the value of K. Like you can, I mean, this is a cross validation setup which we have, which I have shown you over here. But generally, this K value should be chosen as the square root of the total number of test data. So this, right? So, for example, let's say there are 110 rows in test data, then the K values should be taken as a square root of 110. So, that is, let's say, it is around 10.5, right? So, in this case, K value should be 11. It should not be 10, right? So, we generally doesn't prefer the even number. We always go with the odd number, right? So, the concern comes why I am saying it should be odd. Let's say if it is an even number, then what will be happen? I mean, when there is two classes of element and the two classes are equally representing the new element, the classifier will have confused in deciding the class of new element. So generally, to avoid such a situation, K should be taken as odd, right? That is the idea. Now, as I told you, the best approach is this one which I have followed over here. Give the different value of k and check the performance, and we can select the value of k for which the performance is highest, right? So basically, if I will say, generally this KNN model is used on the data which is labeled. That means data should have some column with the name, and there should be a target variable that need to be predicted. And this KNN model works well in case of a small data set. There is another important takeaway point where the data set does not contain millions of records, right? So this KNN model decide this nearest neighbor depending on the distance from the neighboring point to the new data point by using this any one of this method, right? So that is the important point how this KNN works. Now the concern comes regarding the application of KNN, right? So basically, number of applications are there. We use this KNN classification, our regression. Basically, we use this KNN for the anomaly detection. We use this KNN in recommendation system. In medical diagnosis also we use it. Credit risk assessment, right? So many, I mean, it is having a huge application, but there is a limitation. So as I told you, if there is a huge data set, we generally avoid to use this KNN model. Now these are the advantage and disadvantage of KNN model. So no training phase, the model quickly adopt the new data, simple and easy to understand, versatile, suitable for both classification and regression tasks, robust to noise training data, and effective for non-linear relationship. That is again important point. The disadvantage is computationally expensive because we are calculating the distance between 2 points. Now think about, say for corresponding to each, I mean for the new data we have to find out the distance respective to all the data points. So if the dimension is high, then this become a computationally expensive process, right? So it is sensitive to the choice of distance metric and k value. So which distance metric you are using and what is your k value. So actually this entire KNN is basically depending on these two parameters. It is a memory intensive as it requires storing in the entire data set for the prediction, prone to biases when dealing with the imbalanced data set.
Now let me summarize what we have learned so far in this KNN classifier. So basically this KNN classifier is an algorithm that classify a new data point based on its nearest neighbors. In KNN, the important point is the value of k. So the k represent the number of neighbors selected by the model to decide the class of the new data points. Depending on the k value, the result given by the KNN model will change. So this k value is mainly selected based on for which k value the KNN model gives highest accuracy. In KNN model basically uses either the Euclidean distance or Minkowski distance to find out the nearest neighbors. Minkowski distance is a combination of both Euclidean distance and Manhattan distance. Thank you.